Hey everybody, welcome back. Morgan here. We're going to be talking about the electrochemistry lectures again today, and we are on page 6 of 12 of that outline. And I had sent you home last time, hoping that you would spend some time doing questions 4 through 8 to see what you can come up with. These are the questions dealing with electrolysis, which is when we send an electric current through a solution to force what is an otherwise non-spontaneous chemical reaction to happen. So in question 4, we're asked what mass of copper can be produced by the electrolysis of a copper 2, it's important, sulfate solution for 1 hour at a current of 10 amps. 10 amps is a huge amount of current, okay? That would kill you if you were to be hit with that. So Cu2 plus 2 electrons gives you Cu, will be our ratio. We are starting out with 10.0 coulombs per second, which is an amp, and we are multiplying that by 1.00 hours. And then for a unit conversion, we know that 1 hour has 3,600 seconds. So hour and seconds cancel. And we now know the amount of charge that went through that solution, which would be about 36,000 coulombs. Now, at this point, we use the Faraday constant, 96,485 coulombs per mole of electron. That gets us onto the roadmap. We can use this equation, 2 moles of electrons for 1 mole of copper, and then we can say that 1 mole of copper is 63.55 grams of copper. So coulombs is gone, moles of electron are gone, moles of copper are gone, and that gives us about 11.9 grams of copper. 3 sig figs is appropriate for that question. 3 there, 3 there. Okay? So that's a pretty standard electrolysis style question. Okay? This, of course, is assuming 100% yield, which probably won't happen. Okay? But close enough for what we're doing as a textbook problem. Okay, so now, in this next question, calculate the amount of current, so we're actually looking for amps for coulombs per second, necessary to deposit 2.00 grams of platinum from a solution of PT Cl62-. So that is a platinum 4+ that we are working with this time. So we have 2.00 grams of platinum. And we're going to need to say 1 mole of platinum. Convert it to grams. That's 195 grams of platinum. And then we'll say that 1 mole of platinum needs 4 moles of electrons. That comes from the 4+ charge. So now, moles of platinum, moles of electrons, to get rid of moles of electrons, 96,485 coulombs per mole of electrons. That cancels. And we're not quite there. Current is coulombs per second. So what I need to divide by is the 2 hours. So 1 over 2.0 hours, and then also, I'll multiply the sign there, 1 hour has 3,600 seconds. So hours cancels, and we now have coulombs per second. And that comes out to be about 0.55 coulombs per second, or 0.55 amps. All right, so that's a slightly different version of the question, okay? Like I said in the last lecture, if you know how to use units, you can make this happen. but still we want to try to go for understanding. Now, the next three questions are much more interesting because they actually allow us to not just think a little bit about what's going on, but to do something that's really quite useful in identifying different metals and charges and things like that. So, the same quantity of charge that was deposited by 0.583 grams of silver is passed through a solution of gold, so that means the same number of coulombs. And 0.355 grams of gold was formed. What is the oxidation number of gold? Well, I guess we need to know how many coulombs that is. So let's start off with 0.583 grams of silver. 1 mole of silver is 107.868 grams of silver. And we can say that 1 mole of silver gives us 1 mole of electrons. And that is 0.00540 moles of electrons. So the amount of charge that created that mole of electrons out of this reaction, remember it's Ag+, it's the only known charge for silver, is also going to go through that gold. So we need to figure out how many moles of gold that is. 0.355 grams of gold and 1 mole of gold, okay, is 196.97 grams of gold. And that equals 0.0018 moles of gold. So I know the moles of electrons that pass through here, so a ratio of these is going to tell me the charge. 0.00540 moles of electrons for 0.0018 moles of gold, and that's a 3-to-1 ratio. So that must mean that the reaction was Au3 plus 3 electrons gives you Au. So the gold had a 3 plus charge. All right? So, interesting and different, but very useful. I actually had to do that as an experiment my senior year in college, I remember. Okay? So number 7. We have a solution, doesn't say what metal, but it's got a 3 plus ion. We run a 5.0 amp current for 10 minutes, and we get 1.99 grams of the metal is plated out. What's the molar mass of the metal? Okay, so 5.0 coulombs per second times 10.0 minutes times 1 minute as 60 seconds. So minutes are gone, seconds are gone. That gets us to coulombs. 96,485 coulombs per mole of electron. And this is something that we interpret from what we see right here. It's a 3 plus charge. So 3 moles of electrons for 1 mole. And we'll just call that metal M. We don't actually know what it is. Okay? So moles of electrons cancels. Coulombs cancels. So this comes out to be 0.01036 moles of M. Now for the molecular weight or the molar mass, 1.99 grams of the metal divided by 0.01036 moles. Remember, use your units. Molar mass is grams per mole. And that equals 192.0 grams per mole. Now, if we were to look at a periodic table, that's iridium, okay? For all of you that are fans of the Avengers film that came out in 2012, the one that the comic book people referred to as Avengers Assemble. Okay, so It took 156.2 seconds for a 3 amp current to plate 0.233 grams of metal from a solution of M with a 2 plus. What is the metal? Okay, so again, we're starting out with that 3.00 coulombs per second times 156.2 seconds, seconds cancels, times 96,485 coulombs per mole of electrons. The coulombs cancels. Now, since it says it's an M2 plus, I can say 2 moles of electrons for 1 mole of M. Okay? And when I run that through, I get 0.00243 moles of M. Okay, so 0.233 grams, which is a given, divided by the 0.00243 moles, and that comes out to be about 95.9 grams per mole. I look at a periodic table, and that is molybdenum. All right, so those are some very good questions, good to practice, okay? I always enjoyed these types of questions because it's problem-solving technique, and if you get stuck, you just let the units kind of guide you in what's going to happen next, okay? All right, so thanks for tuning in, and we'll continue on with this in the next lecture. Morgan signing off.